Hello friends, welcome to engineering tutorial. So in the next series of videos we'll be discussing some problems, some questions on relative velocity. We have already discussed the basic concepts related to relative velocity in one dimension. Okay, we have covered that. So these questions will also be on relative velocity in one dimension. Okay, so this is the first question, and it is given that two railway tracks are running parallel along the west east direction. Okay, and along one track a train A moves with the speed of 54 kilometer per hour from west to east. The direction is important. And along the second track train B moves with a speed of 90 kilometers per hour from east to west. Find the relative velocity of train B with respect to train A and relative velocity of ground with respect to B. And another important thing which I have missed is that we have to find all the velocities in meter per second. Okay, that is asked. So let us first draw the diagrams here. So here first the direction, that is very important. Okay, so east, west, north, south, we are only concerned with east, west. So here it has been given that there are two trains. Okay, let's say this is train 1 or train A, sorry, train A. Okay, it is moving from west to east, that is along this direction with a speed of, this is train A, with a speed of 54 kilometers per hour. Let us convert directly to meter per second because we have been asked to give the result in terms of meter per second. So it will be 54 into 1000 meters. 1 hour is 60 minutes, 1 minute is 60 seconds, so it will be 60 into 60 seconds. So it is coming around 54. Okay, 15 meters per second. Okay, this is the velocity of train A in meters per second. Then we have train B moving with a speed of 90 kilometers per hour from east to west. Okay, this. Okay, from east to west, that is along this direction. Okay, this, it is 90 kilometers per hour in meter per second. 90 again into 1000 meters by 3600 seconds, so it is coming around 25. Okay, 25 meter per second. So actually it will be minus 90 because it is moving along this direction towards the negative axis. So it will be minus 90, it will be minus 25 meters per second. So this here, again let me highlight it here, this is plus 15 meter per second, this is minus 25 meters per second. Because it is along the negative x-axis, this is along the positive x-axis. One dimension, relative velocity in one dimension. This is train B. So this is here train B. Okay, so now the first part of the question is to find the relative velocity of B with respect to A, train B with respect to A. Now if you remember, the basic format of relative velocity, which I've already explained. Relative velocity, it is always expressed in this notation, which means, what is the meaning of this notation? V subscript 1 2 is relative velocity of object 1 with respect to object 2, and mathematically it is expressed as V1 minus V2. And another important thing is that the sign of V1 and V2, it also depends on their direction. So plus minus V1 minus plus minus V2. This is very important. So here it has been asked relative velocity of B with respect to A. So this means this VBA, which is relative velocity of train B with respect to A. This will be VB minus VA. So we'll put the sign here. VB is minus 25 meters per second, okay, minus 25, because it is moving towards the left, towards the negative x-axis. That's why minus magnitude is 25. So it is minus 25 meters per second, okay. This is VB part. Then minus, then what is VA? Whether it is plus or minus, we'll see. Here VA is the velocity of train A. It is plus 15 meter per second. It's moving along the positive x-axis towards the right side, okay, and magnitude is 15. So it is minus plus 15 meters per second. I am deliberately using this minus and plus sign so that it is clear what this expression means, okay. So it is minus 25 meters per second minus 15 meters per second, it is equal to minus 40 meters per second. That is VB, a relative velocity of train B with respect to train A. So what this essentially means is, suppose someone is standing on the train. Well, it is not safe to stand on the train, but let's just assume that someone is standing on the train and train A, and he or she observes train B. Assuming that train A is stationary, then it will appear to this man as if train B is moving away from this position where he is standing at a velocity of 40 meters per second. Okay, the train B is moving away with 40 meters per second. As it is moving away towards the left hand side, that's why minus sign. Okay, that is the first part of the question. Then is relative velocity of ground with respect to train B. So again, we know that ground velocity is 0. Yes, but earth is moving, but for now we will just assume that velocity of ground is 0 meters per second because it is stationary. So it has been asked relative velocity of ground with respect to train B. Again, it will be expressed as VGB, that is relative velocity of ground or earth with respect to train B. It will be velocity of ground or velocity of earth minus velocity of train B. Now here velocity of ground or earth is 0 meters per second and velocity of train B is minus 25 meters per second. We have already discussed minus 25 meters per second. So here it is plus 25 meters per second. So this is velocity of ground with respect to train B. So here what this tells us, that suppose someone is standing on train B, okay, and he or she observes any stationary object on the ground, let's say a tree, okay, let's say a tree, okay. So for that person, it will appear as if the tree on the ground, which is on the ground, is moving away from him in this direction with a speed of 25 meters per second. As it is moving towards the right hand side, that's why plus sign, magnitude is 25. So here train B is the reference on which the person is standing. Assuming it to be stationary, it will appear, again it will appear to him or her that the tree which is located on the ground is moving away from him with a velocity of 25 meter per second. Okay, this is the meaning of relative velocity. So these are very simple questions, but I am taking time to make you understand the essence of what relative velocity is. Okay, so this is the first question which we have discussed. So in first case, the answer is, with respect to A as the reference, train A as the reference, the relative velocity of B with respect to A is 40 meters per second and minus 40, and here it is relative velocity of ground with respect to B is 25 meters per second. Okay. So here is another question. So it has been given that consider two trains A and B moving along parallel tracks with the same velocity in the same direction. Okay, let the velocity of each train be 50 kilometers per hour. Calculate their relative velocities. So it is a very simple and straightforward question, but an important concept here. So here let us say we have two trains, okay, they are moving in the same direction. So whether in this direction or towards the right side or towards the left side doesn't matter. So here let's say it is moving in this direction. This is train A moving with 50 kilometers per hour and train B also moving with 50 kilometers per hour. So the basic expression of relative velocity is this: relative velocity of object 1 with respect to object 2. Both of them here it is plus because we have taken it towards the right side. So here relative velocity of train A with respect to train B, this is equal to V1 minus V2. This is the expression. So here it will be VA minus VB, the relative velocity of train A with respect to train B, which is 50 kilometers per hour minus 50 kilometers per hour, which is 0 kilometer per hour. And same relative velocity of train B with respect to train A, VB minus VA, which is same 50 minus 50, 0 kilometers per hour. So here what it essentially means, that if someone is standing on train B or someone is standing on train A, it will appear as if both the trains are at rest with respect to each other. Okay, even though they are moving actually, but because their direction is same, their velocity is same, it will appear as if they are stationary, they are still. Okay, so same thing if we take the opposite direction also, it doesn't change the case. Let's say we have again two vehicles or two trains again which are moving in the opposite direction, same 50 kilometers per hour, 50 kilometers per hour, minus minus. So here also the relative velocity will be minus 50 minus minus 50. it will be equal to minus 50 plus 50, which is equal to 0 kilometers per hour. Okay, so the same, it will appear as if both the trains are at rest with respect to each other because they are moving in the same direction with the same velocity. Okay, so this is a very important and good question related to a simple straightforward question, but a good question, conceptual, concept wise related to relative velocity.